think it's working? I don't know. We'll see. Disappeared. So 250 grams of platinum to how many particles of platinum? So I can do this like by trying to remember the rules, or I can just do it with the system. If particles over here, what needs to be here?
Particles.
I know this needs to be particles. But what needs to happen to grams here? I need to get rid of grams of platinum. But there's not something that goes one to the other, right? What is the intermediate thing? Yeah, here, because I know that a mole is how many grams of platinum?
6. Oh no, I don't know.
195? Okay, we're just going to go with that. And then I know that 1 mole is how many particles?
6 to 10. 6 all to 2.
Right, 6.02 times 10 to the 23rd. So now moles cancel, grams of platinum cancel, and then this was 1.25. So that's around 2.5, 4.5, 7.5, something like that? 7.5 times 10 to the 23rd? I could be wrong. I'm doing it off the top of my head. 7.7? Okay. But thank you, Oscar, for correcting that. 7.7 times 10 to the 23rd particles. Questions? Now, obviously, I could have just done it the other way. If I have 250 grams of platinum, I just use those 4 rules that we talked about, and I just divide by the molar mass of platinum, which is 195 grams per mole, right? When I do this, that gives me approximately 1.25 moles of platinum. Now, I take 1.25 moles of platinum times Avogadro's number, which is 6.02 times 10 to the 23rd, and that's particles per mole. Moles cancel there, and I'm left with my answer of 7.7. Oops, 7.7 particles. That's exactly how many. 7.7 times 10 to the 23rd particles. Okay, so that's doing it just by looking at units. This is actually something called unit analysis. It's kind of like breaking the system up slowly, saying, I have this, what do I want? Well, I have to get to moles first and that. So the classic term, which you will have to remember, is grams. I should write this so you can read it. That's usually, everybody does moles by MOL. Grams to moles, then it goes moles to moles, then it becomes moles to grams. This is the reaction. For example, if I take CH4 plus O2, that gives you CO2 plus H2O. And then that's 1, that's 2, and that's 2.
This is the balance.
Yeah, this is a balanced chemical equation. So this is literally the way this works. And then the ratios tell you. Do you have to know this right now?
Yeah.
No, so relax. Don't get all stressed. Don't get freaked out. All these letters, numbers. Just calm down. I'm just showing you this moles to moles comes from there. For example, if I have 1 mole of methane gas, how many moles of carbon dioxide am I going to have? If I have 1 here, I'm going to have 1 there because they match. Yes? Do you see that? What if I have 1 mole of of methane gas? 1 mole of methane gas. How many moles of water am I going to produce? See, if I burn 1 mole of methane gas, how many moles of water comes out of this reaction? 2. See? Because it's 1 to 2. And then that's what you use here. But this is going to be a huge part of, it's kind of like the seminal concept behind this class. That you can look at reactants and look at the reaction and know how much of the products you're going to get. Because this is reactants. This is the reaction. And this is the product. And we'll learn that later, but that's fine. Okay, so what do you need to be able to do? This. you know this is going to come on your test or quiz. There is going to be manual control. There's wow, that's weird. Oop, did you see that? It like bounced on the ground and went right through this. Okay, well anyways, there's going to be one of these problems on your quiz. Question? Did that record or not? Yes, it did.